question is like this. Using the property of determinant, prove that in the first part, the determinant 1a square, 1b square, 1c square is equal to a minus b minus c minus a. In the second part, we have to prove that the determinant 1 abc a cube b cube c cube is equal to a minus b minus c minus a into a plus b plus c. So to solve the first part, we take the left hand side and we have been given the determinant 1a square, 1b square, 1c square, and we have to prove that this determinant is equal to a minus b minus c minus a. Now, on observing the determinant, what I see here is that first column contain all the three elements as 1. So I can easily make two of the elements of the first column as equal to 0 by applying the property that R2 is changed to R2 minus R1 and R3 is changed to R3 minus R1. Okay, so applying the property, here you can see I have subtracted the elements of the second row from the first row to obtain 1 minus 1, b minus a and b square minus a square. And similarly, I have subtracted the element of the third row to obtain 1 minus 1, c minus a, c square minus a square from the elements of the first row. Okay, so this can be written equal to 1a square, 0 b minus a, b square minus a square, 0 c minus a, c square minus a square. Factorizing these terms, I can write the determinant as 1a square, 0 b minus a. Factors of b square minus a square is b plus a, b minus a, and 0 c minus a. The factors of c square minus a square are c plus a, c minus a, right? Further, we can see that from the second row, we can take b minus a as common, and c minus a can be taken common from the third row. Okay, so taking b minus a common from R2 and c minus a common from R3, I'm going to get this as equal to b minus a into c minus a, and the remaining determinant would be 1a square. Taking b minus a common, here it would be 1, b minus a common, here it would be b plus a. Similarly, c minus a common, here it would be 1, and taking c minus a common, here it would be c plus a. Okay, now the determinant has been simplified into a very easy form. Now we can expand the determinant. So expanding along this determinant C1, it would be written as 1 into the determinant obtained by removing the first row and first column, that is 1 into 1 b plus a, 1 c plus a. And because the remaining terms of the first column are 0, therefore we need not have to worry about the remaining two terms. They would be equal to 0, so plus 0 plus 0. Okay, now we are going to expand this determinant. So we are going to obtain b minus a into c minus a into c plus a minus b minus a. This a cancels out, so I'm going to obtain this as equal to c minus b. Okay, now in the given question we have to prove that the determinant was equal to a minus b minus c minus a. Now here the terms are not in this form. So to convert them in this order, in this form, so I'm going to take first of all minus 1 common from the first bracket b minus a. So I'm going to obtain this as minus 1 into a minus b. Okay, and remaining two terms as it is. So a minus b is obtained. Second term is b minus c. Here it is c minus b. So this minus 1 is going to multiply in this bracket to obtain b minus c. And rearranging the terms, I'm going to get this as a minus b, b minus c, and the c minus a is exactly what is required. So this proves the question. To solve the second part, we take the left hand side, and in the left hand side we have been given the determinant 1a cube, 1b cube, 1c cube, and we have to prove that this is equal to a minus b minus c minus a into a plus b plus c, right? So first thing I observe here is this, that the first row have all the three elements as equal to 1, right? So the determinant can be converted into very easy form by making the two elements of the first row as equal to 0. Okay, so applying C2 is changed to C2 minus C1 and C3 is changed to C3 minus C1, right? So this will be equal to 1a cube, 1 minus 1. Again, next term would be b minus a and a cube minus b cube. Similarly, 1 minus 1, c minus a, c cube minus a cube. So this will be equal to 1a cube, 0 b minus a, and on factorizing b cube minus a cube, I am going to get this as b minus a into b square plus ab. And similarly, c cube minus a cube can be written as c minus a into c square plus ab, and these two terms, these two values, 1 minus 1 is 0 and c minus a as it is. Okay, now from the second column I see here is that b minus a can be taken common, and from the third row I can take c minus a as common. So taking b minus a common from C2 and c minus a common from C3, I am going to obtain the determinant as b minus a into c minus a, 1a cube, 0 1 b square plus ab, 0 1 c square plus a square plus ca. Okay, solving further, now I am going to expand this determinant along the first row. So expanding along the first row, I am going to obtain this as equal to b minus a into c minus a into 1 into the determinant obtained by removing the first row and first column, that is 1 into 1 b square plus ab, c square plus a square plus ca, and the second two terms are written as 0 because 0 into any value would be equal to 0. So next two terms are written as equal to 0. This value would be equal to b minus a into c minus a, and on solving this determinant I am going to obtain c square plus a square plus ca minus b square plus a square plus ab. Okay, so this a square cancels out, and we are going to obtain this as b minus a into c minus a. Cancelling a square, cancelling a square and a square, I am going to obtain c square plus ca minus b square minus ab. Okay, writing c square minus a square separately and ca minus ab separately, I am going to obtain this as b minus a into c square minus b square plus ca minus ab. Factorizing these terms and taking a common, I am going to obtain this as b minus a into c plus b into c minus b, and this a common, I am going to get a into c minus b. Taking c minus b common from these two terms, I am going to obtain this as b minus a into c minus a into c minus b into c plus b plus a. Okay, now we have to prove that a minus b minus c minus a into a plus b plus c. That is what we have to prove. So the terms are about the same, but they are not exactly equal. So first of all, I am going to take minus 1 common from this term b minus a to obtain a minus b, right? Multiply here to obtain b minus c, and this c minus a is exactly what is required, and rearranging these terms as a plus b plus c to obtain the value as a minus b minus c minus a into a plus b plus c. So this proves the required value. Okay.